Hello everyone, I am positive. Fuji P101, a small controller, has been really popular these days. It is being discussed everywhere. I read thousands of posts in the Tion group. Then, in the past 2 days, I have seen many people discussing the joystick assembly controlled by this small handle, so today I am here to share some of my experiences with you. Many friends said that this rocker assembly very difficult to calibrate. In fact, this rocker assembly, because its size is really too small. You can see in normal. This full-size rocker assembly. The size is different by at least 2 or 3 turns. Then it's so small. Fully 3D drawn. Calibration requires certain skills. Otherwise, you will see that the center position of the joystick will be a little floating. Or when you hit the edge, it will be wrong value. So today I will share with you. Use this trick of mine to make this little rocker calibrated to a relatively perfect state. Then jump out first. Enter the rocker calibration interface. In the system settings, hardware interface. Then turn down. Swivel wheel. Go to this calibration interface. Click in. So what's the first step? It starts by clicking confirm. At the beginning. At this time, place both sides of the joystick in the middle. Because this side of the throttle lever, you need to take a look at it mechanically. Probably in the middle. Probably just put it in the middle. Then don't move the other rods. And then this time, gently move the lever in the middle. Let it return to the neutral position on both sides. Or shake the controller gently like this. Because the accuracy of this rocker is really too high. Too sensitive. Click to confirm when in the middle position. Good. At this time it allows you to hit all the boundaries. Then this step is the most critical. This cannot be used with our traditional remote control. Just hit it and it's over. We need to hit it gently and slowly to its 4 edges. And especially when you get to the edge. Don't hit the point with more calibration with force. Not in place. Just touch this boundary lightly and that's it. Gently to the border. The bottom is also gently reaching the border. Has anyone hit it below? Then gently hit it on top. Be sure not to push too hard to the edge. Let it exceed this line. Because after all it is made of such a small size assembly. And then is it made of metal? It is a material of nylon. Then hit it to the left. Just gently push it to the end. At this point, click Save again. That's it. Then I will exit at this time. Let's take a look at this accuracy. View inside the channel. I'm shaking now. My midpoints are all normal. I'll move at will. First of all, the middle position does not float. Then the throttle lever. Then hit the left or right direction. Okay, now the calibration is complete. Basically you won't see any drift. Then I saw many friends on the internet. Maybe during calibration. Or maybe he hit it too hard. Or it's this little rocker. Be a little rough on it. There will be a slight deviation when it is full. For example, after normal calibration, hit 94. Like 95, 96. It does not reach the value of 100. Then it's time to calibrate. I used too much force when I reached that boundary. For example, under normal circumstances, we use the avoidance controller. Possibly when calibrating. Just make 4 sides and it's done. But this little rocker, don't swing like this. This shaking will definitely exceed the one that calibrates the boundaries. Then let me tell you a little more about it. Hall's rocker. How it works. This is from Foss. It's the 579 metal 3D painting assembly. I'll zoom in. There's a magnet in here. There's a magnet right here in the center. And then here is a sensor. Sensing magnet position. Then when the joystick moves. Watch when the joystick moves. The angle and position of this magnet. It all changes back and forth. Use this sensor. Read a signal that changes in value. Magnetic induction signal. Then it directly outputs the digital signal. Put it in the remote control. So in fact, this accuracy. Do you want such a big rocker? When I move, the movement of the magnet. Relatively speaking, it is quite obvious. Becomes such a small one. A gentle faint breeze. There will be changes in the value of this joystick. My current rocker. The adjustment is not quite tight. Just average tightness. Just touch it and it will change. So this looks like. Maybe sometimes there will be a little bit in the middle. For example, bumping. When it shakes, there is a bit of mid-range drift in the middle. But I like this kind of thing. It's okay to put it in the middle. Then touch it lightly. It can have numerical changes. That means this rocker. Its resolution must be very high. Then I have seen some remote controls. Put it here in the middle here. I touch it lightly. It doesn't change much. Then what I thought it might be is this dead zone is set relatively large. Either it's its resolution. Maybe not that high. When you move a little in the middle, there is no change in the values. But the small P101, this metal, this Hall rocker does. Of course it would be better if it were metal. But now I feel it has. At least the resolution and response accuracy. It has indeed reached a very high level. But since it is this, so its anti-deformation ability. Even I'm kind of pressing down on this plastic. It may have some numerical changes. I think this is acceptable. Because normally when I'm actually flying, what I need is the true output accuracy of the joystick. Just how much I move. How much can it output? It's not that I can't tell the difference between 1 and 2 when I move a little bit. Or I can't tell the difference between 3 and 4.